over multiple courses, the data engineering, DevOps, databricks, right? And data engineering something is that I specialize in. So before we talk into what all we're going to cover, how is it going to plan out, right? First of all, let's see what is the structure of the course going to be. Now, we'll have an hour of daily classes, all right? So it's gonna be 1 hour, 1 hour, 15 minutes, 1 hour, 20 minutes, depending on the topic that we are on, right? Sometimes it will get extended, sometimes it will be just 1 hour or 1 hour, 15 minutes, right? So average class duration that we have is 1 hour, 15 minutes for every class. And this course will be more than 40 hours in total, all right? Maybe around something 45 hours, 50 hours is going to be the total duration of this course. And that is going to be the duration that we're going to spend on various topics, right? We'll be giving you hands-on exercises on Azure portal. All right. So I'll guide you how you can create your free Azure account, right? And that free Azure account will give you almost, I think, $200 of credit. That's around 17 to 18,000 rupees that you'll get on the Azure platform. And I'll also guide you through the cost aspect of what resources you create and how much is it going to cost. Now, as of now, you do not know what resources are, what is the cost associated with them. So you are blank, right? You're absolutely blank, and that is the expectation that I'll keep with myself before we begin this course. My expectations would be that you have absolutely zero experience of cloud. You have no knowledge what cloud computing is. You have no idea about what Azure is, right? You're hearing the name Azure for the first time. And that is the level that we start from. And by the end of this course, you will be happily creating a dedicated SQL pool, working with data exploration using serverless SQL pool. You will be proficient with databricks. You'll be proficient with data factory. You'll be doing incremental data loading using data factory. You'll be combining data bricks with data factory. You'll understand everything. So that is the level that we need to achieve, where you're able to work with various Azure resources. You know what Synapse is, you're able to work with Synapse, you're able to create data warehouses in Azure, right? And manage and monitor those warehouses as well. You're able to create pipelines using data factory, you're able to create mapping data flows, right? Uh, you're able to do CI/CD with Databricks, right? So all of those things are what we are going to learn towards the end of the class, all right, or the training. Now, on top of the hands-on exercises that you'll get, we'll also be sharing documents and practice labs. So I'll just show you how it's going to look like. Uh, 1 second. All right. So if you see here, this is like the content that we have. There'll be more added for the Databricks. So every topic wise, we'll be giving you, a certain set of labs that you're going to perform, along with a document that will be explaining that particular part of the course that you have, right? For example, let's go to serverless SQL pool. So you can find, 4 labs associated with serverless SQL pool. So this will be on top of what we'll already do in the class. All right. So we'll be doing multiple labs in the class. And on top of that, you will do these hands-on exercises on your own. So, in total, you'll be doing some 8, 9, 10 exercises every topic, right? Because as somebody has rightly said, right, that you do not learn by just reading it, you learn by doing it, right? So if you actually need to learn Azure, if you actually need to learn Azure data engineering, you have to get your hands dirty on the Azure portal. So I'll give you step-by-step instructions on the portal, explaining you what is what, how you're going to work with the resources, everything I'll explain you there. And then once we are done with, some basic to advanced level exercises in the class, this is what you have to perform on your own, right? Similarly, for the dedicated SQL pool, we have various labs and the document that explains what dedicated SQL pool is, right? So the learning content on top of what we already cover in the class, along with the labs, will be available for to you for every topic that we cover. All right. So after every topic, you will be informed to perform those labs, and you have to perform those labs and let me know that you are able to do it, right? Whatever exercises have been given to you, whatever sample data sets you require are already present in the folder. So let's say there is a lab that requires a particular, CSV file or a Parquet file or a JSON file. So those files are added to those individual folders so that you don't have to go anywhere else. Under one roof, you're going to do complete hands-on practice. All right. So documentations of the topics that we're going to cover along with the practice labs will be given to you, right? Then we are going to cover everything from the base to the high. All right. So we'll start from the very basics. I know you have no idea about what Azure is, what Synapse is, what Data Factory is, what Stream Analytics is, what PySpark is, right? Even PySpark we'll cover in the class. So I know you have absolutely zero idea about those topics. So that is why we'll start from the very basics. We'll first understand Python in the class. Some basic understanding of the Python we'll do. Once we are done with Python, once we understand, various data collection, we understand lists, dictionaries, tuples, sets, everything we are done. How do you write basic Python functions and all? Once you have that basic level of understanding, then we'll move to PySpark. All right. So I'll teach you what PySpark is, how you can install it on your machine and start practicing it, right? Or how you can practice PySpark on the Spark pool in Synapse, or how you can practice PySpark on Databricks, right? So every option will be given to you to practice, right? Even for Databricks, you can create a free account through Azure, or you can create a Databricks free community edition account, which will let you, run your scripts, run your notebooks on the cloud. All right. So we'll start everything from the very basics and we'll go towards the advanced topics. All right. Then whatever discussion we have, whatever videos are there, right? Whatever the day's recording is, every day's lecture is being recorded, and that recording will be put into uh, the LMS portal that we have. So I think a while ago you would have seen that LMS portal. So on that LMS portal, we'll be uploading all of these videos. Day-wise recordings will be updated so that in case, right? Ideally, you should not miss the class, but in case you were stuck in something and you end up missing the class, you will have access to at least the recordings so that, next day when you want to attend the next class, you can go through this previous 1 hour, 1 hour, 15 minutes lecture, right, in your own sweet time and be up to date with what we are doing in the class, right? After that, after all the training, all the hands-on exercises and everything, we'll be sharing a question bank, the interview questions, and these interview questions are updated. And, these are the interview questions that you can expect people asking you in the current times, right? Recently, what they're asking, what is the trend? And these interview questions will be given to you topic wise. So for Synapse, you have these questions. For Databricks, you'll have a set of 50 to 70, 80 questions. For Data Factory, you will have around a set of 50 to 60 questions, right? So like that, these questions will be divided section wise. And then we'll be sharing some sample resumes also, right? That the experiences that you can add on top of project. Now, one thing which is not mentioned here, that we'll be doing at least 2 projects, all right? So we'll be covering 2 projects as well. These projects will be related to whatever we have covered in the class, right? Now, essentially, when you are working with a particular topic, right? For example, you're doing Synapse, or let's say you're working with databases in Azure. The hands-on exercises that you do in the class will focus more on that one single resource, right? So for example, Data Factory exercises will focus more on Data Factory. Synapse exercises will focus more on Synapse. Databricks exercises will focus more on Databricks. But the projects are going to be the place where we are going to combine all of this knowledge. All right. How do I make use of Databricks along with Data Factory, along with Synapse warehouse, dedicated SQL pool? How do I combine these resources? How do these resources talk to each other? All of that we are going to cover. All right. So this is going to be the structure of the course that we have. All right. Now, on top of this, what all will we cover? What all topics are we going to cover? So by the end of this course, all right, you will be familiar with hands-on experience, with a complete understanding of Databricks, Fabrics. We are also covering Fabrics. All right. Fabrics is not an Azure resource. I hope everybody is aware of that. But since Microsoft is now using Fabrics for data engineering, we will also take a look at Fabrics wherever it is necessary. All right. For example, the one lake architecture. We'll try to understand how to use data factory in Fabrics. We'll do that in the class. How do I create my warehouse in Fabrics? We'll do that in class. Even though Fabric has not been widely adopted as of now, right? It's a very new technology, but you will have experience and understanding of what Fabric is. Even in Fabrics, you will be doing a lot of hands-on, right? So that is also covered. So we'll start from the very basics. That is going to be cloud fundamentals, from answering questions like what is cloud computing, what are the different cloud service models, right? What is infrastructure as a service, what is platform as a service, what is software as a service. From answering those questions to going into deeper depth of what is an Azure Resource Manager, what is an Azure Resource Manager template, what is a subscription, what is a management group, right? What is a resource group, what is a zone, what is a fault domain, update domains. So we'll start from the very basics and we'll go to a point where you're able to answer a lot of questions. Almost you'll be able to write AZ 900. All right. So for those of you who do not know, AZ 900 is the Microsoft Azure Fundamental Certification exam. All right. So this basically certifies your skill in Azure fundamentals, that the person is, equipped with the knowledge of what Azure cloud computing is, what services does it offer. So by the end of cloud fundamentals and Azure infrastructure, you'll be completely familiar with the syllabus of AZ 900, and that is what we are going to cover as well. All right. Then in Azure infrastructure and cloud fundamentals, we'll also talk about identity and access management. See, I can go ahead and directly start with databases and storage, right? But when I have to give access to my Synapse Analytics workspace on top of my storage account, let's say from Synapse, I want to connect to the storage account, right? So this is my Synapse, this is my storage, and I want to connect it. But have I set up any security principle? Without a security principle, I'll not be able to do it. But first of all, what is a security principle? You don't know that, right? So these are all the things that we'll be covering in the class. What is a security principle? How do you give access to a user? How do you give access to a group? How do you create a service principle? How do you create a managed identity, right? What are all these things? First of all, you need to understand that therefore, a significant portion, when I say significant, basically around a week time we'll spend on these two topics because they are very important. Until and unless you know these two topics very clearly, you will not be able to understand other topics. Or like when I go to Azure Storage and I want to create a storage account, it asks me for a resource group, but I don't know what a resource group, right? So that is going to be problematic. So that is why we focus on the fundamentals first. We'll start with the basics of Azure. We'll cover everything that you need to know. There'll not be a single topic that we'll miss out on, where you have, let's say, uh, you have to create a particular resource in databricks, or let's say in data factory, and you do not know what it does, right? Every single setting that you do, every single configuration that you do, we are going to cover that in depth. Once we are done with the basics, we start with databases. All right. So we'll cover SQL databases, we'll cover NoSQL databases such as Cosmos DB. So Azure SQL database and Azure Cosmos DB are the two services that we are going to cover in depth. All right. Once we are done with databases, we move on to the very important topic, which is my Azure storage, which gives me two options. One is a blob storage, and the other one is something very important in terms of data engineering. Almost everywhere you go to LinkedIn today, you find out all the job opportunities related to data engineer. If it mentions Azure, which almost 70 to 80% of the jobs do, you will always find a term there called ADLS. All right. What is ADLS? That is the storage. That is the big data storage that you have. That is Azure Data Lake Storage. All right. So what is a data lake? How do you create a data lake? Before data lake, what did we have? The blob storage, the basic storage functionality, that is, or the basic storage resource that is present in Azure, which is my blob storage. And then how do we move from a blob storage to ADLS, which is very important, right? People ask, and it's a requirement. You should be aware of what ADLS is. You should be able to understand what it offers, right? What are access control lists in ADLS, right? What is the directory structure? What is POSIX compliance that is present there? So all of this we will try and understand in the class itself. So we'll do blob storage also, and we'll do ADLS also. So these are the two basic storage that we'll cover. Once we are done with the storage, we'll move to Synapse. Now, storage is important because we take use of the storage account in Synapse Analytics. We take use of the databases in Synapse Analytics. That is why we've done those topics first. So in Synapse, we'll have three pools, right? The serverless, the dedicated, and the Spark pool. So serverless pool, dedicated SQL pool, and Spark pool. Three pools, three types of data processing, three different architectures. We'll try and understand this. Here, the Spark pool lets you run your PySpark based applications, right? It lets you run your Spark applications. Dedicated SQL pool is basically the data warehousing in Azure. If you want to ask what is the data warehouse in Azure called, it is the dedicated SQL pool within the Synapse Analytics workspace. All right. So back in the day, earlier, we had a service called Azure Data Warehouse, Azure SQL Data Warehouse. But now that service has been brought under the umbrella term of Azure Synapse Analytics, right? So we'll understand this first. Then we move on to Data Factory. Again, it's a very comprehensive resource with a lot of topics to cover, right? In Data Factory, we'll see first of all, how do you, just use Data Factory to create pipelines? What are the artifacts that you create, right? What is a linked service? What is a data set? So basic understanding once we have, then we move on to more complex topics of creating the pipelines. All right. So then we'll see how do you ingest data using Azure Data Factory. We'll try and ingest data from multiple sources. We'll try and ingest it from a data lake storage. We'll try and ingest it from an HTTPS, or let's say a web-based storage, right? We'll then move on to with Data Factory to understand what mapping data flows are, right? Now, I know all these terms are pretty new to you. You'll not have an understanding of them, but trust me, by the end of this course, you'll be a pro at Data Factory. You'll be creating pipelines for fun, and they're very easy, right? That is the whole purpose of creating a service like Azure Data Factory, which is a low code, no code solution of creating your data transformation and data movement pipelines. All right. So once we are done with that, we'll see how do you process streaming data in Azure through Azure Stream Analytics, real-time processing, live data processing, right? Until now, Synapse Data Factory, they're really good for batch data processing, but then we'll see how do you use Stream Analytics to process data, streaming data set. All right. Then once we are done with this, we move on to Python and PySpark. We'll try and understand because Python is kind of a prerequisite, but still we cover it in the class. But there is another prerequisite that we do not cover in the class, and that is, so before you take this course, you have to make sure that you have at least basic understanding of SQL. All right. And it's not pretty hard to understand SQL, right? It's, I think, 4 or 5 hours if you give, you will be a beginner in SQL. Another 5 to 6 hours if you spend, you will be on an intermediate level in SQL, right? So if you're spending 10 hours on SQL, you will be good to go, right? So SQL is one of the prerequisites. Python is a prerequisite, but we covered it to an extent in the class itself, right? Because I'm pretty sure most of you will not be from a coding background, right? If you know Python, it's really good. If you do not know Python, we'll put the base in the class itself where you'll be able to understand the basics of Python, and then building on top of it is your job, right? PySpark, however, we'll start from the very basics and we'll cover it to an advanced level. Why? Because PySpark is used in two places. One, Azure Databricks. Second, Synapse Spark Pool. All right. So once we are doing Synapse here, we'll not cover Spark Pool as of now. In the beginning, we'll not touch Spark Pool because to cover Spark Pool, you need understanding of PySpark. That is why once we're done with PySpark, we'll then cover Spark Pool, and then we'll move on to Databricks. Within Databricks, we'll cover a lot of topics. All right. Within Databricks, we'll start with the simple creation of the resource itself, how it is tightly coupled with Azure, right? How is Databricks coupled with Azure, other cloud-based services also? What does it offer, right? And then creating notebooks here. Once we are done with that, we'll be creating data frames, we'll be creating tables, we'll be using Hive Metastore, we'll be talking about the Unity catalog, we'll be talking about the medallion architecture, we are going to be talking about Lakehouse architecture, right? Then we'll see Databricks jobs, Delta Live tables, which is how you create pipelines in Databricks, right? All of that we'll cover. All right, source control with Databricks also we will cover. We'll see how you can use tools like GitHub and Azure DevOps to do source control over here in their code. And that we'll see in Data Factory also. In Data Factory, we'll also see something called as self-hosted integration runtime, right? So when you want to transfer data from on-premises environment to the cloud environment, how do you make use of the self-hosted integration runtime? That is also something we'll cover. And then there's going to be Microsoft Fabrics, right? So Fabrics will put it everywhere, in individual topics. For example, when we are doing Synapse, I'll show you how you can use Fabrics to create a data warehouse in Fabrics also. When you are doing Data Factory, I'll show you how you can use Fabrics there also. And then separately also, we'll have a discussion on Fabric. All right, we'll cover all the important topics there. How it actually works, how the architecture is, how it stores the data, right, in the one lake. So all of that we'll cover. And then there are other certain topics also that we have not mentioned here, but it's something that you will be covering in depth. For example, Microsoft Entra ID, right? Now that is the identity and access management solution in Azure, and you need to know that, all right? Entra ID is important because working with Databricks and all, you need to authenticate these resources onto your Azure-based resources. Now, to do that, you need to understand what Entra ID is, right? So that is also something that we'll understand in the Azure infrastructure and cloud fundamentals. All right, enter ID, then various monitoring tools. How do I monitor my services? Now, all of these services, most of them, such as Synapse, Data Factory, Stream Analytics, Databricks, they come with inbuilt monitors, right? They will have their own monitors, but how do I manage the overall Azure environment? That we'll see through Azure Monitor Service. So these are the core topics that we are going to cover. Is that clear to all of you? Yes. Now we need to answer just two very basic questions. Why data engineering and what is data engineering? All right. So when we try and answer this question, why data engineering, there's a lot of thing that a lot of thought that goes into this. Because in today's digital age, you can consider data to be the new oil. You remember how the oil was discovered and then the entire world went mad behind oil, right? Similarly, data is the new oil, right? And data engineering is the engine that is going to refine this oil, right? Now, which are the most, I would say, rich countries that you've heard of? Countries that are able to refine this oil, they're able to work with it, right? And that is what is going to be true for every organization, right? Any organization that is able to refine the data, collect the data, and make it clean, ready for analysis, ready for utilization, is going to be a big organization. But who do they need to do all of this? They need skilled data engineers like yourself. All right. The organizations worldwide are accelerating their adoption, of data driven decisions, all right, or data driven decision making, cloud computing, data analytics, right? So the demand for skilled data engineers in today's market, it has reached an unprecedented height. Everybody wants to utilize their data, all right? And nowhere is this transformation more evident in the current scenario that we have, all right? Now, the global data engineering market is on a remarkable growth trajectory, all right? And this is not something that I have made up. This is directly quoted from a paper by AIM Research. There's an organization called AIM Research. So they basically publish a lot of articles around, all right, and they do a lot of research on the state of data engineering, especially in India, right? And global as well, right? But I will talk about India today, right? And you can understand something happening in India is also happening globally, right? So today the market is projected to expand from almost around $29 billion, right? Uh, $29 billion the market was in 2023, by the way. So in 2023, the data engineering market was almost around $29 billion, which will reach, and hold your breath, $175 billion by 2030. So you can imagine the growth, because there's something else that contributes to this factor. Now, I read a very interesting thing that almost 90% of the data in this world was generated in last 4 to 5 years. Imagine, more than 90%. More than 90% of the data that we have today was generated in the span of last 4 to 5 years. All right. And this is more important today on Azure because now today organizations are migrating to the cloud. Organizations are migrating their enterprise to the cloud. All right. And that is the exponential growth for Azure and data engineering. Everybody wants to host their resources on the cloud. And today, let me tell you, Azure and AWS have almost similar market share when it comes to the cloud computing market share that they have. GCP has almost around, I think, uh, the last I knew it was around 10%, but I think it would have increased a bit. Azure and AWS are almost around 33, 34, 35%, right? They're around that time. But the difference between Azure and AWS is that Azure is a very highly growing market, whereas AWS is not having the growth that Azure is having today. All right. That is also one of the reports that you can check, right? And that makes Azure very important for you to understand. All right. Among all the clouds that you know, Azure is, created by Microsoft. Now you imagine the kind of penetration that Microsoft has in the current IT infrastructure, right? They're changing everything. All right. And they're going to change this cloud computing infrastructure also because AWS had a head start ahead of Azure. They had a head start. All right. And to be very honest, previously Azure services were not that great. I have been using, Azure since a very long time. I know personally that they were not very great, but in the last 2, 3 years, right? I think since 2023, 2022, 2023, Azure have changed the entire game. All right. They have completely changed the entire game, and that is the reason why they have a very high growth rate compared to AWS. And I think it would have already taken over AWS by now because the report that I am referring to, I think I read it a few months ago, right? And they were almost on a similar level. And if not, then it will, in the very near future, it will obviously take over AWS and become the leading cloud provider or cloud service provider. All right. So all the organizations today, they don't want to rely on on-premises environment. They don't want to build their own data centers. And we'll understand the reason. In this course, we'll try and understand that reason as well as to why organizations don't want to create their own data center. It's very difficult. All right. It's very expensive. It's very difficult to manage, right? And cloud services, they offer you, these data centers with a fraction of the cost. All right. I'll show you in the class also a cost comparison between setting up a data center in Azure versus setting up your own data center, right? And it's gonna, blow your minds away that, the difference, the sheer difference in the cost that is there. Now, cost also and headache also, because in Azure, nothing is your headache. The hardware, the infrastructure is not your headache. That is Microsoft's headache. So that is also something that we try and understand. So we were talking about why data engineering today, right? And I gave you some numbers. Now let me give you some more numbers. By 2025, which is this year, the BFSI, all right, the BFSI sector, which is your banking, finance, and all that, right? That is the most dominant sector, all right, employing almost 60% of data engineers today. All right. So 60% of the data engineers today are employed by BFSI sector. All right. And this number was almost 49% in 2024. All right. So your banking, financial services, insurance, these organizations are employing the most data engineers. All right. So 49%, almost 50%, right? And a 20% growth in a single year, right? So this growth actually tells you that this sector is relentlessly in pursuit of, advanced analytics, for digital banking, fraud detection, financial automation, right? And data engineers in the BFSI are uh, doing really good, right? They're building robust data pipelines that power the real-time decision making and helps us with secure financial transactions, right? Which is happening now. Apart from BFSI, pharma, healthcare, they're also the top, I would say, players when it comes to data engineering. All right. So the growth is being seen in these sectors. All right, and the expansion is driven by the breakthroughs in the drug discovery, the rise of telemedicine, and the integration of AI-driven health analytics. Now, with the evolution of AI, right, we want to today use AI in every sector possible. But what does AI need in order to make smart decisions? What does AI need? AI needs data, right? Is it going to be raw data? No, it needs clean and transform data. Who's going to clean and transform this data? Data engineers. So that is the kind of effect that data engineers have. All right. So the AI bandwagon that everybody is riding on, they'll not be able to perform if we don't have skilled data engineers who are going to provide them with cleaned, transformed, formatted data. All right. So now, India's technological landscape, you're all aware of, right? The cities of Bangalore, Hyderabad, right? And Bangalore in particular, right? It leads the charge with almost around 15 to 16,000 open data engineering positions today, all right? And across all, I would say, job search engines that you know about, right? There are almost 49 to 50,000 job openings around that number currently there. All right. So this is the data that I'm giving you from a couple of weeks ago. So for 50,000, almost 50,000 job openings are currently there uh, in requirement to Azure, in requirement to data engineering. And the keyword Azure, all right, I'll show it to you tomorrow maybe. The keyword Azure is mentioned in almost 80% of those job postings. So people want to do data engineering, people want to hire data engineers, they want to transform the data because everybody wants to make smart decisions today. And the smart decisions will not be smart if you're not learning from the past, right? So how do people learn from the past? People learn from the past by analyzing the data, the previous data, right? And to do that, they need clean data, they need transform data, and that is what the data engineers are going to give them. All right. So it's a very rewarding career path. All right. Now, once we understand why data engineering, all right, in today's market, let's also understand what data engineers actually do. All right. So if anybody here today is not from a data engineering background, they've not worked with data before, right? Let's try and understand what you're going to do. All right, what your job profile going to be. Data engineers are basically the architects and the builders of the entire data infrastructure. All right. So you'll be designing and creating and building pipelines. All right. So you'll be responsible to create these pipelines. So you'll create these robust pipelines that collect data, that processes data, that moves data from various locations, right? If you want to pick up data from a database, put it into another place. If you want to pick up a data from a storage account, put it into a data warehouse, right? So all of that you are going to build. Data cleaning and transformation you are going to do, because data can be messy, it can be inconsistent. So data engineers will clean the data, they will validate the data, they'll transform this data into a structured format, because everybody wants a structured format. If I just throw random numbers at you, you'll not be able to understand. But if I create a proper structure, a table with a proper column, right, where what data is present in that column, if I create that chart in a very structured way, it'll become easier for you to understand. That is why everybody wants data in a structured form. So we have now today, and majority of the data getting generated today is unstructured data, right? So I hope everybody here knows that there are three types of uh, you know data, if you call it: structured, semi-structured, unstructured. Structured is the data that you can write in a tabular format. You have rows, you have columns, you have predefined columns, your relational databases, right? They store structured data. The second type of data is semi-structured data, which does not have a clear structure, but it can be converted into a structure. All right. So it's midway. All right. So that is your JSON files. I can convert a JSON file into a table. All right. I can do that. The third is unstructured data, which can never be converted into a table. All right. Maybe it can be converted to a table, but it is not present in the tabular format, such as documents, images, videos, and majority of the data that is getting generated today is images, videos, and such files, right? So most of the data getting generated today is unstructured. And as a data engineer, it is our job to bring that into a structured format so that, my AI models could learn from it, my business analysts could work with it, right? All right. Now, on top of that, you will also ensure the data quality and the reliability of the data, right? You're going to implement checks, you're going to implement monitoring, you're going to set up alerts to ensure that data is accurate, data is up to date, and the pipelines that you're building, they're running successfully. If they're not running successfully, you will get an alert. You have to then sit and analyze as to why it did not run successfully, right? You will also be optimizing data storage, right? Petabytes of data is getting generated. How do you store it in an efficient manner, right? How do you minimize the cost? Because cloud economics is also a term that is becoming very popular today. All right, we call it cloud. All right. So how we have economists between us, right? People who are aware of financial terms, people who are aware of how to improve finances. Similarly, now there is a new profile getting created on the cloud called cloud economics or a cloud economist. They are people who are going to help you to reduce your spending on the cloud. All right. And cloud economics is the subject to understand how I can save money on the cloud, because these are a subscription based model. Whatever you do on the cloud, you end up paying for it. You have to pay for it, right? A simple act of downloading a file from the storage account will charge you certain amount. So whatever you do, instead of uploading, right? Uploading is free of cost. Downloading is having some charge associated with it. So how do I minimize this cost, right? So there are a lot of ways in which we do that, right? We'll be covering a lot of ways in the class also. When it comes to storage, we'll see the different access tiers that exist. We'll understand the life cycle management in the blob storage, right? So that is why I told you, we are not going to cover just the data engineering topics. All right. I'm not going to open Synapse directly and show you that the data is present there. You bring it here like this, and then within Synapse, what you can do. No, we are going to have a comprehensive understanding of the cloud environment, right? Because I don't want you to be in a position that you understand Synapse, you understand Data Factory, but when somebody asks you how you going to give access to Synapse onto the data lake, you have no idea. That should not happen, right? So as a successful data engineer, as somebody who has a lot of in-depth understanding of the subject, you should be able to answer every question, even though it may not be a direct data engineering question, but it is related to your work, so you should be able to answer it. And that is why we'll cover all these topics, right? Now, as a data engineer, you will be supporting two very important profiles. That is uh, data scientists, all right, and data analysts. So data scientists also and data analysts also will depend on you, because analysts, right? They require clean data. They require formatted data. Data scientists also need clean and formatted data to train their models. So both of these job profiles actually rely on your work as a data engineer. All right, and you'll be automating the ETL tasks also. Now, when you discuss what is the effect that data engineering brings, right? So if you want to understand what actually data engineering solves, right? So we need to talk about a problem, right? And the problem is what a very big organization had. Now, I'm not sure how many of you are aware of it. Okay, that was not the correct thing to say. I think everybody is aware of it. You're all aware of Netflix? Yes? You've all heard the name? Now, Netflix had a problem.
Yeah, yes.
Right? Netflix had a big problem. As a subscription-based streaming service, they were facing a challenge of low customer retention, right? They were facing a very great challenge where people were just not renewing their subscription. And this is a real story. There's a whole, you know what do you call it, they've created a case study out of it. And it's out there, you can read. Users would sign up, watch content for a short period, maybe a month or two, and then they were seeing that a lot of people were dropping off. Now that is a problem with a lot of organizations today. People come to their websites, people enjoy their content, but there's no retention happening, right? It's not just Netflix. A lot of organization will hire you as a data engineer to make sure that this problem gets addressed. So users would sign up, they'll watch content for a while, and then they would cancel their subscription, right? And this was
Yeah, yes,
affecting
right.
Netflix's growth and profitability, right? So data engineers then came into the picture. To solve this problem, Netflix brought in their data engineers. What the data engineers started doing were, first they built a unified data platform. All right. They created a platform that was capable of ingesting and processing massive volumes of data. All right. Now, where was this massive volume of data getting generated? This was getting generated on netflix.com. So what was this data? First of all, user activity log. First of all, they started collecting data as to what the user is doing on their portal. You go to netflix.com, what all movies are you clicking on? What all movies you are searching for? Whatever you do on netflix.com, they started collecting that data. All right. So interaction data, search queries, what rating you give. Are you giving a thumbs up? Are you giving a thumbs down? Right? When you're watching a movie, how many times you're pausing it, how many times you're rewinding it, right? Etc. Etc. They were collecting everything. Then they were also collecting your device data, right? What devices are you using to stream the content? How efficient is the streaming, right? Is it buffering a lot? Is it playing correctly, right? In people who watch it on mobile, is the drop rate high there versus people who watch it on a machine, right? That is also what they study. That are the mobile users renewing, or in which type of user are we having, or are we facing the lowest dropout, the highest dropout? All right. So then once they started creating this, they created real-time data pipelines. All right. So they implemented these data pipelines using technologies like Apache Kafka, Apache Spark, and cloud-based storages, right? So these pipelines would collect all of this data, process this data, and store it in a warehouse, right? So they were cleaning it. Uh, you know, uh, there were data engineers who were cleaning this data into and bringing it into a structured format, right? And they were creating the viewing history of a customer, the genre that they like, right? When they're binge watching it, what is the pattern of that? What time of the day or what time of the week are they viewing most of the movies or shows, right? And once Netflix has this golden data about your habits, now what they came up with was something called as personalization. Now they started showing you personalized content. All right. With this data, these data scientists were able to build advanced recommendation algorithm. All right. And these data engineers ensured that these models that the data scientists have created have access to the latest high quality data. All right. And now they started testing this, right? As to if we are giving content or showing content to the user that is very similar to their history or what they like to view, is the user retention going to be more? And they were shocked to see the impact. All right. These personalized recommendations, users were receiving very highly relevant movie and show suggestions now, and that increased the engagement and satisfaction. All right. And by surfacing content that users now like to enjoy, these subscribers were always engaged. All right. And that reduced the cancellations, and that in turn increased the growth. All right. So they improved the retention, and which led to higher lifetime value per customer and that fueled the Netflix's global expansion story. All right. So this is what the data engineers do, and this is the kind of effect that they bring in. All right. So next is what we are going to discuss now is, all right. So today and tomorrow also we'll have this demo class. So we need to understand a few concepts. All right. So I'll explain a few concepts to you, and then I'll take up your questions. All right. So we can take up your questions today also. If you have those same questions, can be asked tomorrow also. All right. Since tomorrow also we'll have a separate window for discussion where I know you will have a lot of doubts. So we'll have it today also and tomorrow also. But before that, we'll just cover a few topics. All right. So it's kind of a demonstration as to how the class is going to be and how it's going to, function. So I'll just take some 10 minutes and then we'll take your questions. All right. So as I told you, we are going to begin from the very basics. And the most basic question that you can answer is, what is cloud computing? All right. What is cloud computing? What does it offer? All right. And basically trying and understand in what scenarios are you going to use this particular service. Cloud computing is a technology that delivers computing services. Now, please pay very attention to close attention to these terms. We are saying they offer computing services. What are these computing services? This could be servers to create compute. Compute is basically where you have CPU and RAM. We call it compute services. Networking services, such as, let's say, virtual network, creation of a VPN, creation of a firewall. Storage services, we have seen the two types of storage, blob storage and ADLS. Now, if you're not aware of what blob storage is, see, blob is any data that is written in binary format. Binary large objects. That is what blob translates to. So blob means binary large object. So any file that is written in a binary format, right? Mostly your unstructured data. Your images and videos are written in binary format. So blob storage is nothing but a storage that stores this data which is written in binary format, right? And then analytics service. Services such as databricks, HD Insights, all these services. So any resource that I want is available on the cloud. For example, let's say I have a requirement where I want to, let's say I have created an algorithm. Right? This is a machine learning algorithm that I've created. Now I need to train this. All right. Now to train this algorithm, I require first of all 2 terabytes of data, right? And I need high compute. What is high compute? That means high CPU and RAM. Correct? Now I take a look at my laptop, which is, people call it a dabba laptop. My laptop has i3, 8 GB RAM, 512 GB, not SSD. Let's say it's a hard disk. Will I be able to do this training on my machine? Yes or no? Is it possible for me to do this? The answer is no, I cannot. So instead, what do? I go to a website called portal.azure.com. There I go to something called as a virtual machine, and I create a Windows machine. Now this Windows machine that I created has 4 terabyte of SSD storage. It has 16 cores CPU, 64 GB RAM. Can I do it on this Windows virtual machine that I've created? The answer is yes. Now, what is the difference between two scenarios? First, I was using a physical machine that I already have, but it was not capable enough. What was the substitute to this? I could go to the market, buy a new machine, right? But that would require a lot of money, right? Buying a new machine is a lot of money. And here, I'm able to provision a virtual machine, which is exactly like a new machine, but only on the cloud. I can access it through a browser. All right, do not get to hold this machine. I can access it over the browser, over the internet. And I'm getting the same machine, at what cost? Let's say some 20 rupees for an hour. All right. So now you understand the kind of cost benefit that cloud computing gives you. I'm able to create the same machine that is able to perform my task at 20 rupees an hour. And it's actually 20 rupees an hour. All right. Not with 16 core 64 GB, but an 8 core 16 GB machine will cost you around 15 to 16 rupees. All right. This could be around 30, maybe 30. So I just have to spend 30 rupees an hour, right? If the model takes, let's say the algorithm, the model that I'm trying to create, it takes, let's say 20 hours. So I'll just have to spend 600 rupees. That is it. In 600 rupees, my training is done. My model is ready. All right. Now, if I go here, this would have taken upward of 1 lakhs. This machine, a new one, would have taken upward of 1 lakhs. So you see the cost effectiveness. Similarly, if I want to create a storage, I can create one storage, or I can buy a storage device, or I can create that storage on, again, portal.azure.com. I just have to go create a storage account. And within that storage account, I can store as much data as I want. And I just have to pay hourly rent. I just have to pay this rent, which is very cheap compared to your new storage account. It's this rent is very cheap. So cloud computing is basically a model where you get access to all of these resources, and there are many resources. If I show you, right, I'll show it to you tomorrow. There are many resources here. All right, compute resources, database resources, data engineering resources, AI-based resources. You name it and it's there. I want to host a web application, there is a resource for that. I want to create an API, there's a resource for that. I want to store my data, there's a resource for that. I want to create a firewall, the virtual machine that I created, I want to put those virtual machines behind a firewall, there's a firewall resource. I want to create a VPN, there's a VPN resource. So whatever you need, a resource exists on the cloud that you can create, and in a fraction of the cost, you'll get the resource up and running. Now, getting the resource up and running is not the point, but how much time do you take to create a virtual machine? 2 minutes. You are getting the service up and ready, working in 2 minutes. Compare it to a situation where you had to go to the market and buy a new device. Compare it to a scenario where in your office you need to set up a server, right? You need to set up a small data center. Just imagine the time it will take, the approvals, how the approval flows, how it is going to be approved, how you get a vendor, then how much duration the vendor takes to supply those parts to you, then how do you set it up, then how do you get people to manage it. You imagine the kind of effort that you have to put in there versus kind of effort that you have to put in here, where in 30 minutes you'll be able to provision whatever resource you want. So that is cloud computing, basically getting resources but over the internet. These resources are present in the Azure data center, which I and you cannot access. All right, then where did this very important cloud computing come from, right? How did organization work back in the day? So back in the day, every organization was building their own data center, and we used to call it private cloud. Private cloud means inside my office campus, I will build one data center. All right, you would have seen in many organizations, they have a dedicated data center building, right? So we have those data center buildings in private cloud. This is also called as on premises, right? So the company, the organization would create a building, right? So in this building, they will call it a data center. They will buy all the hardware, They'll get the network devices installed, the network connectivity made. They will install the cooling system. They will hire the admins, right? They will manage the security. Everything from hardware to network to cooling to admin to security, everything is my headache to manage in this data center. I have to put in money for everything. Hardwares are very expensive. For everything, I have to put in a money. So there's a huge cost, huge cost that goes into creation of this data center. And there are two types of costs. All right. If I just have to explain you, there are two types of cost. One is called as a capex. The other one is called as an opex. Capex stands for capital expenditure. Now, when I'm creating this building, I'm putting in it a lot of money. Yes, a lot of money goes into creation of a building, building it. When I'm buying the hardware, I'm putting a lot of one-time cost. So capital expenditure can also be thought as a one-time cost. You just have to pay this once, and then you don't have to pay it again. All right, it's a one-time cost. Only pay once. Once I've created the building, I don't have to create the building again. Once I've bought the hardware, I don't have to buy it again. Once I've installed the network infrastructure, I don't have to buy it again. Once I have the cooling system in place, I don't have to install it again, right? But then there are certain costs which are operational. Operational means they are recurring. Can you name some recurring costs? Can anybody name some recurring costs?
Like if in your network, you might have to change the cables for connectivity.
Maintenance cost, yes, absolutely. Maintenance is recurring. What else?
Hardware change.
Salaries to the admins,
Electricity cost you need to give.
electricity cost, internet cost. So any cost which is a monthly recurring cost is called as an operational expenditure or OPEX. CapEx is capital expenditure, one-time investment, initial investment. OPEX is operational expenditure, repeating cost. So within a data center, you have both capital also while creating the data center and operational also. That is a recurring cost. All right. So this was the private cloud. Who had access to this data center within the campus? Only the employees. Only the employees of that company would be able to access this data center. All right. Nobody from outside. Then something changed. So this is the model that was being followed. Every company used to build their own data centers. They used to hire some admins. They used to, the employees of that organization used to, work with it. Then something changed. And you know what changed? A big company, and I'm giving you an example. All right, this is how it started. There's a big corporation that came in, and they created a very large data center. All right, let's say this is Microsoft. So Microsoft came to Bangalore, and Microsoft thought, let's create a very big data center, and they built it. They built this data center. Now Microsoft got very excited, and they built a very huge data center, thinking that we'll get a lot of business and we'll use this data center. But over the period, what Microsoft realized was that they were not able to use more than 20% of the capacity. Now, another situation like this would be when you have earned a lot of money and you built a house, right? Everybody has a dream of building a house. Let's say you also built a house, and because, building your first house is very exciting. So you built 4 floors of it. So there was ground, there was first, there's second, there was third. And you're a family of three. All right. You, your partner, and your small one kid. A family of three is sufficiently, they're sufficiently going to be able to live in the ground floor itself. Do they need to occupy all the other floors? No. But now you put in a lot of money and excitement that you want a big house. You've created a big house. So there's a lot of investment that has gone in. But like any other investment, how do you get a return on this investment? You always want a return on your investment. So how do you get a return from these floors? What do you do?
Rented.
I gave
Put
them
it
out on
on
rent.
rent.
Yes. You put it on rent. You've put in a lot of money. Now you need to regain some money. Similarly, Microsoft here in Bangalore, they put in a lot of money to build this 80% of the data center, but it was not generating any revenue. They were not utilizing it. Either you utilize it, either it is of use to you. That is also, value for money. But then if you're not using it, it's a waste. What Microsoft did, they said, okay, fine, we are not using this data center, but you know what we'll do? We'll let organizations from outside use this. All right. So now they said that this space is available on rent. But what did happen? Did they ask, other organizations to send their employees to this data center and work? No, that will be very chaotic, right? I cannot have if 20 companies have taken small places here, right? So it's not rent available on rent for everybody, for a single person, right? It's available on rent for everybody. So one company came, took this much of space, another company came, took this much of space, another company came, took this much of space, another company came like this. So a lot of companies came and started occupying these small spaces within this data center. So now will Microsoft allow employees from all the companies to come and visit the data center? It said no. Since a lot of you are coming in, we'll make one thing clear, that you have to access this space over the internet only. Only over the internet you're going to access this space. And that is where public cloud was born. We call it public cloud. Public cloud, introduced the concept of rental services in terms of servers, in terms of storages. This was the first time where, let's say I am a new player. All right, I don't have the funds to create a data center. It's very expensive. It takes millions of dollars to create a big data center. I have just started, a new startup, and I don't have the resources to create a data center. What do I do? This was a perfect opportunity for me to come and make use of this data center offered by Microsoft. It was very cheap, and startups, big corporations also, companies like Wipro, TCS, Infosys, they also started adopting this. Why? Because now these companies could focus more on delivering the services rather than focusing on managing the data center. Not just for these companies, any company. People don't want to spend time on management and maintenance of their data centers until and unless they are storing very high quality data. For example, you would have seen banks will always have their own data center. Defense organizations will always have their own data center. Research organizations will always have their own data centers. That is because they value their data. Banks value their data a lot, right? So that is why they want to have a complete control over it. It's not that they will not have a complete control over here. They do get complete control. They get better security on the cloud. But then it's a psychological fact that anything hosted over the internet is not considered to be safe, right? So that is why banks continue to have their own data centers. Defense organization like DRDO, research organizations like ISRO, right? They try to keep their own data centers, right? They try to maintain their own data centers. So this is how public cloud was born. Now, do I have capex here in public cloud? What do you think? Do I have capex? As a user of public cloud, do I have capital expenditure here?
No, no,
No. No. I am not going to build this data center. Microsoft did. So capital expenditure would have been for Microsoft. But as a user, I don't have to pay a single money for capex. Do I have operational expenditure here?
no.
No.
Yes, there is
Yes.
operational expenditure. That may not be the electricity bill. It may not be the salary. It may not be the internet bills. But what about the rent that I have to pay every month? Yes. So you are paying the rent every month of creating those services, and that is a recurring cost. So that is considered to be operational expenditure. So now if somebody asks you, also there's one more type of cloud. So this was the public cloud, which is owned by the cloud service provider. Here, cloud service provider is basically either Microsoft in terms of Azure, Amazon in terms of AWS, Google in terms of GCP, right? and they provide resources and services to multiple organizations and users. Everybody can use these services, and you access these services over the network. That is one thing. Then came private cloud. Not came private cloud. Basically, private cloud was what existed before public cloud. Organizations would create their own data centers, right? And organization is itself responsible for operating the services that they provide here, and it does not provide access to users outside the organization. Only my employees can access it, right? So that was private cloud. Now let's take example of TCS. TCS would have created their own data centers. It's a very old organization. They would have created multiple data centers around the world. Yes, sorry, not the world, but at least in India, they would have created multiple data centers. Yes. And now I'm saying that TCS also moved to Azure. So they have their private also. Obviously, if they've created this data center, they'll not throw it away. They'll continue to use it. And they have the public also. So such cloud where we have private also and public also, we call it as a hybrid cloud environment. All right. The name I think is not visible here. It is called as a hybrid cloud environment. So it combines both public and private cloud. All right. So now I have a very interesting question before we close this. Close this as in the demonstration, and we start taking up your questions. Which is the most expensive cloud from whatever you saw?
Private
Which
cloud.
cloud?
Private cloud.
Private. All right. Private. Others? No guesses?
Hybrid.
Hybrid. All right. Okay. So one different answer we have now. One to hybrid, two to private. Anyone else who wants to try it out? All right. Let's see. What are the costs associated? There is capex. There is OPEX, but there are two types of OPEX. I'll write OPEX also and I'll write rent also. Right? So capex, OPEX, and rent. What all cloud models do I have? I have public,
Public. Private and hybrid.
private, and all right. Now you have to answer. Do I have capex in public cloud?
No.
Do I have OPEX in public cloud?
Yes.
That is rent,
No.
right?
No, no. Rent. Okay.
So I don't have to pay electricity bill and all, but I do pay rent.
Yes. Yes.
Let's come to private cloud. Do I have capex in private cloud?
Yes.
Yes.
Do I have OPEX in private cloud?
Yes.
Do I pay any rent in private cloud?
No. No.
No, right? In hybrid cloud, do I have capex?
Yes.
Yes.
Do I have OPEX?
Yes.
Yes.
Do I have rent?
Yes.
Will
Which is the
also be
most
there.
expensive cloud?
Hybrid, because
What?
it's a public plus private.
Hybrid.
Yes. You're basically utilizing two different clouds, right?
Yes.
So if the workload is the same, then you end up paying most in the hybrid cloud. And hybrid cloud is considered to be the most complex cloud also, right? It is very complex. So now you have understanding of what cloud computing very basically means and what all cloud models are there and how they came into the picture. Yes?
Yes.
All right. So now we'll take your questions. Whatever questions you have, please go ahead. One second.
I have one question. What are
Yeah,
the
go on.
prerequisites for your data engineering? Like, any each part concept is required?
Yeah. So as I told, right, there is only one prerequisite to this course, and that prerequisite is SQL. Nothing else. If you do not know SQL, you have time in the beginning, at least around 7, 8 days, 10 days time you have in which you can brush up your SQL skills, right? That is the time when we'll be covering more on the Azure part. We'll be trying to explore the Azure portal. We'll try to you see what is there in Azure, all right? So that is the only prerequisite. Also, before we go to the questions, tomorrow again we have a demo class. All right, it is available for all of you. You can use the same link to join in. All right, if there is any change in that, we'll let you know. But as of now, you can use the same link to join the demo class tomorrow also.
Yes, the same link only, Shreyas.
Yeah. Yeah,
Tomorrow also you can join the same link.
yeah,
Yeah, hello, it's Alex here.
yeah. Hi,
Am I
Alex.
audible?
Yes.
Yeah, yeah. Actually, my requirement is I'm completely working on ETL things in Informatica. Now
Mm-hmm.
they are migrating to Databricks. So I have came here. It is completely for Azure all the products, right? Will it be completely useful for me? That's what my thought.
Your voice broke in between, but did you say Databricks?
Uh, Hello, am I audible now?
Ye Yes, yes, you're audible.
Yeah, my requirement is I'm completely working in ETL project currently. So they are
Mm-hmm.
migrating to Databricks.
Yeah, all right.
Uh,
Hmm. Yes.
so I need complete details in Databricks, but now the course is for complete Azure products. So will it be good for me? That's what my
Yeah, I'll tell you. See, Databricks in itself offers nothing. All right. Databricks couples with a cloud service provider. That is why when you go and see Databricks, right, you'll find Azure Databricks, you'll find Databricks on AWS, you'll find Databricks on GCP. Because Databricks does not have its own resources. It takes resources from the cloud service provider. All right. So therefore,
okay.
whenever you have to use Databricks, you have to use it with either of these cloud providers, either with the Azure, that is why you'll have Azure Databricks, or with AWS, you'll have AWS Databricks, because it does not have its own resources. It does not bring its own compute, right? So the nodes that you create, the cluster that you create actually gets created on Azure. It does not have its own storage. It does not offer its own storage. Therefore, the storage that Databricks uses gets created on Azure. And in this course, we are going to do a very comprehensive understanding of Databricks, right? Now, when you are working with Databricks, you need to know Azure if you're using Azure Databricks, right? So this course is really good fit for you in terms of that. Secondly, when working with Databricks, right, you run Databricks notebooks through Synapse pipelines also and Data Factory pipelines also. All right. So therefore, Synapse knowledge and Data Factory knowledge is also a plus if you want to use Databricks. If you want to improve, let's say have a you created a factory pipeline that executes a notebook within Databricks. All right, it may sound a bit high level to you as of now, but trust me, you'll understand this in the duration of the course. That within Data Factory, I can execute Databricks notebook. That is also an essential learning part, right? So Synapse also you require, Data Factory also you require, Azure you also require, because when working with Databricks, you will make use of the Azure platform. All right. There are a lot of concepts that where you have to fetch files from the storage account. So how do you do that? How many ways are possible for me to connect to the storage account from Databricks? So everything will cover. In Databricks, we are going to cover a lot of things in this course. All right. I think that is going to be the longest section of the course as well, Databricks, because it's very much in demand today. All right. The knowledge of PySpark, the knowledge of the Spark architecture, the knowledge of Databricks is very important. All right. And that is something that we are covering in this course. And with this course, you are getting some additional knowledge also in terms of, as I said, the other Azure based services. All right.
Sure. Thank you. Thank you. Yeah, that
Yeah.
will be. Yeah.
Can you please share like what are the content you will cover?
Yeah. We'll share I think it's there, the training plan in the
Okay.
chat window. Uh, just let me know if you're
Yes.
able to see it. Yeah. Others?
Yes.
All right. If you have any questions, please go ahead. If not, again, as I said, tomorrow is also a demo class. So you can all join in tomorrow also. And if you want to ask any additional questions, I'll be happy to take them up tomorrow as well.
Hi, Shreyas.
Yeah. Hi.
Actually,
So
Uh, can you go one by one?
hello.
Yeah.
Yeah, Gayatri can speak. Yeah. So I have a quick query. So you already have taken the classes in Telepath, right? Like I have So that is it like a same syllabus or it will be different from that?
No, I have not taken classes in IntelliPath. I think
Oh,
you're
okay.
mistaking with somebody else.
Okay, okay then.
Mhm.
I just want to get a knowledge on Azure. I'm not I got like 6 years of experience as an ETL developer. Like I already discussed in the starting of the session. So
Mhm.
I wanted to know about the basic of like even like in the GCP, I have learned the Spark, Spice Spark, and all those stuffs. And like I just did a small project in my college.
Mhm.
I don't have much knowledge in that, and I was an ETL Informatica TDM and Informatica Power Center developer. And now I have 2 years gap. So, do you
Mhm.
think this course will help me to at least crack the interview process here in Canada?
See, how do you explain your gap is the most important part here,
Yeah,
right?
that's I have a like I'm studying so that
Yes, absolutely. Yes. So if you mention it, that you utilize this gap to upskill yourself, to make your skills better, to grow personally and professionally, right? And this is where you learn these technologies and tools also. It's going to be very helpful since you already have a background in ETL, right?
No,
You already know a
to
lot
be
of
very
things.
frank,
Mhm.
I have not done any kind of, everything is like chat GPT. I will do my assignment at the end of the day and submit it. So, to be very frank, I don't have much knowledge. So,
That is why I said, right, we'll be starting from the very basics.
okay. So, this
From the
will be
very basics.
helpful.
If you have, see, as you said, right, you worked on GCP.
Uh,
At least you have an idea as to how cloud
yeah, at least
platforms
I
work,
have idea
right?
what is a
Yes.
tool. I have only those
Yeah.
ideas. I'm
Yeah.
not
So
deep
that's
dive
an
into the
added
core
advantage.
con. Yep.
That's
Okay.
that's an added advantage. So as I said,
Okay.
right, we'll be starting from very basics.
So that will cover the AZ from the AZ 900 till data engineering.
Yes.
Okay.
Complete.
Okay. I don't want like too technical. At least in the interview, right? I can just talk about some terms that I have worked on, this Azure terms, and
See,
like that I
in the
can.
interview, you'll be able to answer all the questions related to Azure data engineering. That is
Okay.
something that you'll be able to achieve very easily
Okay.
if you're regular to the course. That is
Yeah,
uh,
of course. Yeah.
yeah.
Okay. Yep. Okay then.
Yeah.
Thank you.
Yeah. Yeah. I
Uh,
see
Hi,
So what
Aisha
is
at
Sai.
the
the
regular
yeah. Yeah.
timing?
Hi. Yeah. Hi. What do you want to know?
Regular timing, the course
The
timing.
timing is going to be 8 p.m. IST to 9:15 p.m. IST.
Yes.
Okay.
Hmm.
So
Yeah.
Monday to Friday, 8 p.m. to
Yeah.
9:15 p.m.
Yes. Monday to Friday, 8 p.m. to 9:15 p.m.
Hi, Shreyas.
Yeah.
I'm
Hi.
also from data engineering background with the data stage and Teradata, but
Mm-hmm.
my previous project was in fully OLAP system, fully taking care of data warehouse actually.
There were
So I am
warehousing,
deep,
yes.
yeah, deep into data warehouse. So my question here
Mm-hmm.
is, same like Databricks, Snowflakes also comes into the picture. So which is to choose between Snowflakes or Databricks with ADF or Snowflakes with ADF, because both are the same line actually. Both are in the demanding tools. For me, both are easy to learn, but the only thing is which one to choose and which will be the good scope for the future. I know Azure have so many resources, but Snowflakes also handles data warehouse as smooth as possible. But in Azure, it handles more ML and I mean AX related stuffs. It handles. That's what I have researched so far. So my
Mm-hmm.
question to you, Snowflakes or Databricks to you? I mean Databricks in sense total Azure data engineering or Snowflake data engineer. That's what my question. Which to choose between this?
All right. So you want an idea between, what is better to choose between the two? Are you talking in terms of the market demand and all, or?
No. Actually, you gave some research tips actually for Azure,
Mm-hmm.
so you might know
Yes.
aware of Snowflakes as well. So as
Yes.
per your terms, I'm asking you which will be in the good in the market, even in the current and the future scope.
Yes.
Uh,
So
uh,
if you're
mm,
deciding between Snowflake and Databricks, right, in the terms of market trend, right? So growth trajectory, both of them are rapidly growing. All right. And if you see, very high demand in BFSI sector for Snowflake, also for Databricks also. And in terms of job listing, right, which is global in India, you'll find Databricks very high, Snowflake high. All right. So both of them are in demand. Now I think it's your decision as to what you want to go for. All right.
Yeah, correct. But both are in similar terms. Both can be done in the both perspective, right? For
Yeah,
example,
but
if you want to analyze the data, you can do in Snowflake as well, in Databricks as well, right?
see, that is
So
what it offers, right? Databricks offers you streaming data processing also. It offers you big data processing also. It offers you machine learning also. So roles like data engineer, AI engineer, ML platform architect, those roles you can go for with, Databricks. So Databricks compared to Snowflake, it's more high paying and a future proof skill in my recommendation. All right. Many companies use both Snowflake also, Databricks also. So Databricks for more complex processing, right? Uh, and for, analysis reporting purpose, Snowflake.
so
It
in
can be a
Azure
hybrid
also
skill
we
set
can
also. Mhm.
in
Yeah.
Azure also we can store the data warehouse data, right? I mean warehousing data.
Yes, yes. Warehousing data is also possible in Azure.
Okay.
There are
And the
services,
last
there are
question.
dedicated services in Azure that helps you with data warehousing.
Okay. And last question is, as AI booming everywhere, so
Mhm.
how do you think this data engineer will be handling this?
More in
They
demand.
say, yeah.
More data required, more data engineers required.
How about the AI replacing it? Because already we are seeing so many things in the news.
See, AI now, it's more of a buzz, right? But in terms of developers, right, I can assure you, I've seen it with my own eyes. I've seen a lot of developers getting laid off, and projects cutting down the workforce in terms of development, right? But when it comes to profiles where you have to deal with cloud, where you have to deal with data engineering, you have to create custom solutions. There, I don't think AI has a lot of effect as of now. All right, so data scientists, data engineering, these two profiles, I don't think there is a lot of effect of AI as of now.
Yeah, thank you, Ray.
You can be assured.
Okay, but nowadays in data analysis also they are bringing data pipelines also in data analytics tools
Data
also.
analytics,
I,
obviously AI will have some effect, all right? Because analyzing the data with a human mind versus using AI for that, it's obviously something where AI would excel.
okay, thank you.
All right then. So guys, we'll stop the class here today. And I wish to see you. I hope to see you all tomorrow as well, same time. 8 to 9:15, we'll be having this session. It's gonna be a demo session again. Please do join. All right. Thank you, everyone. I'll see you guys tomorrow.
Thank you. Thank you, Sash. Thank you.
Yeah. Yeah. Thanks a lot, guys.
Thank you.